Okay, ladies and gentlemen, you are all welcome to my YouTube channel. Today we are going to look at the Hess law of constant heat summation. So according to the law said that the total enthalpy change of a chemical reaction is equal to the sum of all the enthalpy changes occurring in each step of the chemical reaction. Assuming now you have a reaction which undergoes more than one step, so for you to get the total enthalpy of that reaction is just to add the sum of the individual enthalpy in each of the steps of the reaction. Like for example, now assuming now you have your reactant here and convert it to produce products. But the reaction can actually undergo more than one steps before you get the final product. So in each of the steps of the reaction, an enthalpy of that particular reaction is formed. So like for example, now let's say now you have your reactant and it's converted into products and you generate the enthalpy, that is the enthalpy of that particular reaction. So but the enthalpy of the reaction is usually doesn't change. It's always constant, provided that the reaction undergo even more than one step of the reaction. Like for example, in step one, if you have enthalpy change 1, and also in the step 2 you have also enthalpy change of at step 2. So to get the enthalpy change of the reaction, it is always additive. The enthalpy change of the reaction is always additive, is summative. Therefore, the enthalpy of the reaction is equal to the enthalpy change of at step 1 plus the enthalpy change at step 2. So according to the Hess law of constant heat summation, what he stated that the enthalpy is usually constant irrespective of the route or the way the reaction is being completed. So the enthalpy always remains the same. So there is even another way that you can define or you can actually state the Hess law, which actually said that the enthalpy change of the reaction is independent on the step of the reaction. So in whatever way the enthalpy of the reaction, whether the reaction undergoes multiple steps, but the enthalpy change of the reaction remains constant. It remains the same. So as I said, the enthalpy change of the reaction is always summative. Is the sum of the enthalpy change of individual steps of the reaction. Like now, for example, let's look at the example. Let's now look at this reaction. If you look at this reaction, A is converted into B. You have the enthalpy change of the reaction. But in the same way, the reaction may undergo a multiple step. Like for example, A can be converted to produce X, and then X can be converted to produce Y, and then Y will now finally produce the product B. So you see that in this reaction we have, in this case, we have 3 steps of the reaction. So to get the enthalpy change, of this reaction is just to get the summation of individual enthalpy change at each step of the reaction. So now to get the enthalpy change of the reaction, we are going to say the enthalpy change at step 1 plus the enthalpy change at step 2. Enthalpy change at step 2 plus the enthalpy change at step 3. So that is what the Hess law of constant summation stated, that the enthalpy change of the reaction is the sum of the enthalpy change at individual step of the reaction. So now let's look at, like for example, this is a graphite. A graphite carbon react with oxygen to produce carbon dioxide. So the reactions can actually undergo multiple steps. Like for example, here the graphite can react with half molecule of oxygen gas to produce carbon monoxide, and at the same time, the carbon monoxide react with another half molecule of oxygen to generate carbon dioxide. So you can clearly see that the reaction now undergo multiple steps. So to get the enthalpy change of the formation of carbon dioxide, we are now going to say the enthalpy change at this step plus the enthalpy change at this step. So let's now look at example. Like for example, in the first way, the carbon here react with oxygen to generate carbon dioxide, and the total enthalpy generated and the enthalpy generated, like the enthalpy of this reaction is, the enthalpy change of this reaction is minus 94.05 kilocalories. But if it undergo multiple steps, in the first step, the enthalpy change generated is minus 26.42 kilocal. And then at the step 2, we also have the enthalpy change as minus 67.71 kilocal. So according to the Hess law of constant heat formation, the overall change of the reaction, when you sum these two reactions, it will give you the same enthalpy and same reaction. So if you now add this and this, we are going to get this. Of course, the enthalpy change also will be this minus 26.42 plus minus 67.71 kilocal. And of course, finally we have minus 94.13, which is exactly similar with this. So that is what enthalpy, that is what actually this Hess law of constant heat summation means. That whenever you have a reaction, and if the reaction undergo multiple steps, to get the enthalpy change of the reaction is just to add, or is just to sum the individual enthalpy change at each step of the reaction. So thank you, ladies and gentlemen, and if this is the first time you are coming to my YouTube channel, please subscribe.